we're going to calculate the energy required as 5 times 10 to the third grams of water boils. So again, water is boiling. We're going to go from a liquid to a gas, which is vaporization. And we're going to use our delta H of vaporization. So here's, I went too far. So our mass will go in, well, we're going to use this equation up here. Mass times delta H. Our mass is 5 times 10 to the third grams. Delta H is 2,260 joules per gram. So mass goes here, delta H goes here, grams cancels out. We're left with joules. For number 11, same thing, same equation, except for now, we're given moles. So we use the periodic table to convert moles of water, which is 18 grams per mole. We use periodic table to convert moles to grams, and then we'll have our mass, and then we have our delta H, 2,260, and that will be our equation. For 12, calculate the energy released as 8 times 10 to the 8.016 times 10 to the third grams of steam condenses. The same thing, but opposite. If you guys remember, condensing is going from a gas to a liquid. So we're actually cooling down. So we're going the opposite. It's going to be a negative delta H. We're losing heat. So in this case, all right, it's going to be negative. Okay, let me do that. So we're going to have our mass 8 times 10 to the third grams. And now we're going to have a negative delta H because we're going the opposite way. We're getting getting cooler. And gives us a negative 1.81 times 10 to the 7th joules. The same thing for 13, but of course we're going to make it a little bit difficult. So we got 2 kilomoles, and then we convert kilomoles to moles, where 1 kilomole is equal to 1,000 moles. And then you convert moles to grams using the periodic table. Again, 18 grams per mole for water. We're all doing, it's just water for all these equations. And then again, where steam is condensing, so it's losing heat. So we're going to have a negative delta H.